Hey, this is Mr. Schultz, and we're going to be taking a look at Scatterplots today. So everybody have your packets out and notes all set to take a look here. So, our first example here, we are going to be looking at data that is given as a bunch of individual points. So previously, we've been looking a lot at kind of lines and equations and just kind of doing things that'll look something like that, or or just or just a bunch of straight lines, but usually that's not how data is presented. Usually it's presented as a whole bunch of individual points, and then we end up trying to use those lines to basically make predictions. So let's take a look at what this would look like here. So it says the table below gives 15 students gives the data for 15 students on the number of hours they studied for their math test and their exam test scores. So let's call this graph here, we'll call it test scores. And so student A1, so that'd be this student here, can be represented on the following graph with the ordered pair 145. What was the student's exam score? What was the student's exam score? Well, the 45 in this is referencing this, so their exam score here would be 45. Then it says, how long did the student study? Well, that's where the 1 comes from, right there. So they studied for 1. This is in hours, because that's what it says here, is hours. So, so, so we can add this point to our graph and just go over to the 1 here, then go up to 45. So that's probably roughly right about there. And it says to add the points to go through and add points corresponding to the other 14 students to the scatter plot. So I'll have you pause the video here now and take a second to go through and add in the rest of these points here and the rest of these points here. So for example, if I was going to add my next one, I would go over to 3 hours. I go up to my score of 82. That would be something like here, and so on and so forth. So you can pause the video here. Okay, let's take a look at this all graphed out here. So graphed out, it should look something like this. These just kind of roughly my points here. Then of course I've got my label of hours and the in the exam score. So once I've gone through and added all these, it says for C, do you notice a pattern in the scatter plot? What does this imply about the relationship between the number of hours and the student's exam scores? So it looks like there's a pattern. There's some things that seem to kind of break this pattern, but it seems like that there kind of seems to be this type of emotion that is going on, and that is that this is increasing as you study more hours. So basically, so it seems like the longer you study, the higher the score. Which isn't true for everybody, because you have a couple people here who didn't study quite who studied actually less time than some of these people, and actually scored a higher score. But this is just kind of a general trend. This isn't necessarily true for every single individual. So let's take a look at another one. So this table is showing the fuel efficiency on 13 different cars that were made by Chevy in 2009. So let's call this cars. And it says here the Model 1 is represented on the graph by the order pair 3200 and 23. What is the weight of the car? Well, Model 1 here is based off of this and this, so that's where I'm getting my ordered pair from. Saying that what is the weight? Well, the weight is given to us right there, so that is 3,200 pounds, lbs pounds. And what is the fuel efficiency? Well, that is my 23 miles per gallon, which is all just given to us in the table here, but you can also grab it from your ordered pair there. So I've gone through and I've graphed this first point. So I'm going to pause the video again, and I would like you guys to go through and graph these other points here, and we'll take a look at what that looks like. So you can go ahead and you can pause the video. Okay, so if we take a look at this now, so these are the rest of my points here that I have graphed here, and so we've gone through and we've added these points. Do you notice a pattern? So we kind of see a similar style pattern to the last one, but it seems to be going kind of the opposite. Our data points are kind of leading us down a line that looks kind of like that. So so it looks like this is decreasing, or if we're talking about this in terms of slope, that this is a negative slope. This is a negative slope. So what does that imply about the relationship between the weight of the car, which is our x values here, and the fuel efficiency, which is our y values here? Well, as the weight increases, the fuel efficiency decreases. Let me slide down here. Decreases here. Which makes sense. If one car is heavier than another car, it makes more sense that the lighter car would be able to get more miles per gallon. So this is our third example here, which is going to be based off of these data points. We're going to do a similar thing. We're going to look at this first pair, which is our price, and then our second pair, 65, which is our quality rating, and this is comparing different brands of bike helmets. So let's just call this helmets. And it's saying, what is the quality rating for helmet A? Well, that is 65. We can get that from this, and we can also get it from our chart here. And then what is the price? Well, that is $35, which is once again right there. So so if we look at this, I'm going over to 35, which is my price, and I'm going up to my dollars, which is 65. So it's probably going to be somewhere right about there-ish. So once again, I'll have you pause the video, and I'd like you to go through and graph out the rest of these points here. All right, so now that these are graphed out here, we had that this was the quality rating was 65 and the price was $35 here. So we added those points, and it says, do you notice a pattern here? Well, this one's a little bit harder to see. It doesn't really, I mean, like maybe I could draw something like this, but there's frankly a lot of points way out here. There's 4 of them that kind of break that, and you know, then maybe I could say, well, it's maybe something like this, but even that, you know, I still have kind of some points that are just kind of significantly out there. So this is something where it doesn't look like there's any sort of a pattern. I don't see any sort of a pattern here. It just kind of looks like a big blob. And so what does this imply about the relationship for the price versus its quality? Well, there's no pattern, or there is no, let's call it relationship. No relationship between price and quality. So basically, just because I'm paying more doesn't necessarily mean that I am getting a better helmet, and just because I'm paying less doesn't necessarily mean that I'm going to get a bad helmet. I I could get a good helmet like here if I got this helmet here that has a pretty high rating. Let's see which one that is. That's probably our $20 one here. It's got a fairly good rating, and it's actually one of the cheapest ones. Um, so so there doesn't seem to really be some sort of a pattern there. So let's take a look at the things that we just defined here. So I'm going to slide down here to our first one. So the big thing here before I slide down is that all these here are called scatter plots, and this is just a graph that compares numbers that represent real life situations. And the big thing that we do with them is we talk about that relationship between two quantities. Previously, in our first one, um, in in our first one, let's see what the heck was the first one again. The first one we were talking about test scores. So our first one we talked about this being test scores. We talked about this as fuel efficiency, and we talked about this one as helmets, and just basically said what's our relationship here. So our first blank here is going to be positive correlation. So this is called positive correlation. This is like our test scores example. So if it creates this kind of positive line that you can see something like this, it's a positive correlation, which is kind of like having a positive slope. Our next one down that we talked about was negative correlation. And this is where it dropped down like this. And this was where we were talking about fuel efficiency. And this is kind of like having a negative slope. And then our last example here was no correlation. And this was our helmets. And this is where we couldn't really see any sort of a pattern. It was just kind of this big blob of stuff. So when we have no correlation, that means that there's no relationship between the two variables. So just like we saw that if we spent if we spent a bunch of money, it didn't necessarily mean we got ourselves a really quality a really quality bike helmet. If we spent almost no money, we could still get a good bike helmet. So seem to have no sort of a relationship. So let's practice this here, identifying them as being a positive, a negative, or no correlation. So I'm going to do positive as a plus sign and negative as a subtraction sign, and no correlation. I'm just going to write the word no. So amount of time spent reading and the reading level. So this here would be a positive correlation because the more that you read, you are probably going to get better at it. And I would say that the people that spend more time reading are probably going to have a higher reading level as kind of a general trend. It doesn't mean it's true for absolutely every single person, but a generalized trend. Hair length versus height of 150 women. Well, I don't think there's any sort of relationship between being tall and having long hair because there are lots of people who are tall who have short hair, and lots of people who have tall hair. So I'd say this is no correlation or no relationship. Distance driven versus gas left in the tank. So if I have driven no distance, well, then I'm probably going to have most amount of gas that I can have left in the tank. But if I've driven a long distance, well, I'm not going to have a ton of gas. So this is a negative correlation. This is a negative correlation because as I use more gas, as that is decreasing, my distance would be increasing. Distance walked in a pair of shoes versus the thickness of the sole of the shoes. as my distance increases, so as these numbers here, I'm talking about this in terms of miles. Well, my sole is probably going to start off thick, and it's going to slowly trend downwards and get thinner and thinner. So this is a negative correlation. Thinking through this distance in the gas tank here. So yeah. Yep. This is a good one to also show this example here. So if I'm starting with 12 gallons of gas and I've driven 0 distance, but then I drive like 100 miles, well then I probably had to use some gas, which maybe get down to 6 gallons of gas. So I might see something like that. So again, this why that's that negative correlation. And temperature versus number of ice cream cones sold. So when my temperature is low, like say it's 0, well, there probably is not a lot of people who want ice cream, which is why you see lots of Dairy Queens or different ice cream stores like that will be closed. So you're probably going to see this positive correlation, because as it gets hotter, as it gets up to like 90s and whatnot, well then more and more people like to get ice cream. So we're going to see that positive correlation. So that should be everything for us here. There's homework inside of the packet there, so be sure and check that out. That is going to be due tomorrow. And also, don't forget the CSA review packet that many people started and finished during or after our test yesterday. That is also going to be due tomorrow. So I'll check those 2 things. Tomorrow we'll review stuff with Scatterplots before we take our CSA test on Friday. So that's everything. I will see you tomorrow.